Alright, ladies, so just like you've seen in some of our material, we can see these questions in multiple ways. So the first examples that we did, those were calculation based, where you actually had to find the different values. But you can see these questions in table format. So we're going to do two samples in table format. So the first example here says g of x is a differentiable function and has the given values in the table. So number one, if something is differentiable, it's telling you that condition 2 exists, right? I'm allowed to take the derivative. And the other thing we know is you can only take the derivative if a function is continuous. So this implies that condition 1 and 2 have been met. So let's read the question. It says, must there be a value x equals c in 10, 20 such that g prime of c is equal to 0, justify your answer. So according to our two theorems, which one tells us g prime of c has to equal 0? Good, so Rolle's theorem uses that g prime has to equal 0. So I know I'm going to focus on Rolle's theorem for here. And Rolle's theorem states that I have to have two values that are exactly the same. So in this graph, what I'm going to do is I'm going to take a look and see if there are any numbers that are exactly the same. So if I take a look at the g of x's, what we notice is 10, 23 is the same as 18, 23. Since this is true, we can say yes, comma, since g of 10, because that's when I plugged in x, is equal to g of 18, comma, there exists at least one c. We don't know if there's more than one, but we know there's at least one c in between 10, 18, because that's where we know this happens, such that, and such that is st, such that g prime of c is equal to 0, which is the condition that we're looking for. Then we have to say what we use Rolle's theorem. Rolle's theorem. Okay. So let's go ahead and take a look at part B. It says, must there exist a value x is equal to c in between 10 and 14, and be clear, 10 and 14, such that g prime of c is equal to 0. So now I have to cut this down and look from 10 all the way to 14. So the values I have are 23, 27, and 28. Once again, it says g prime of c has to equal 0, so I still have to use Rolle's theorem. But what we notice is none of those three numbers are the same. So to answer this question, we would say no, comma, there are no known values. So there may be values, but we are not positive that there are values, C1 and C2, so values in between here, in 10, 14, such that, and let me scroll down here, g of C1 is equal to g of C2. G of C2. So what it's saying is none of these equal each other, or none that we knew of. So we can't determine that there is a place g prime of c is equal to 0. Okay. Okay, let's do another chart that we're going to look at. This one is the chart for v. It says v of t is differentiable. Once again, that tells us that I'm continuous and I can take the derivative, so that's the first two conditions, and has the values given in the table below. Must there exist a value t equals c in 20, 14, the interval 20, 14, such that v prime of c is equal to 1/3? Justify your answer. So in this case, I have v prime of c is equal to 1/3. So am I allowed to use Rolle's theorem? No, because Rolle's theorem says I have to equal 0. So I'm going to use the mean value theorem and actually calculate the different slopes. So I need to look from 20 to 44. And so what we're going to do is list down the equation. The equation is v of b, and here our b is 44, minus v of 20, and we're going to find the slope of this graph is 18 minus 8. That gives us 18 minus 8. Oh, I'm sorry. I read my chart wrong. V of 44, V of 20. Down here, I would do 44 minus 20. And then if I plug these in, V of 44 is 18, minus V of 20 is 8, divided by 44 minus 20 is 24. That gives us 10 over 24, and if I reduce that, that will give us 5 over 12. So does this 5 over 12 match the answer right here? No. So how we would state this is no, comma, since V44 minus V of 20 divided by 44 minus 20 is not equal to 1 over 3. There you go. Let's try the next one. It says, must there exist a value t equals c in 44, 80 such that v prime of c is equal to negative 1/6? Justify your answer. So now we need to take a look at the numbers 44 all the way up to 80. Okay, so we do the same thing. I'm going to get v of 80 minus v of 44 divided by 80 minus 44. If we do the math, we get 12 minus 18 divided by 80 minus 44 is 36, and that gives us negative 6 over 36, which gives us negative 1 over 6. So does this answer match this? Yes. So since that's true, what we would say is, let me write it right here. Yes, since v of 80 minus v of 44 over 80 minus 44 is equal to negative 1 over 6, there exists at least one c in, and you have to say it's in 44, 80, such that v prime of c is equal to negative 1 over 6, and you have to say it's by the mean value theorem. Alright, so that's an example of how we see this in a chart. If you take a look at the last two examples in your orange sheet, they look like multiple choice questions. So let's go over how we would take a look at this. It says the function f is differentiable for negative 3 less than or equal to x less than or equal to 1, and f of negative 3 equals f of 1 equals 2. Which of the following statements must be true? More than one or none of your statements may be true. So number one, first thing we should do is don't even look at 1, 2, 3. Let's draw what we know. So if I draw this, what I do know is I go from negative 3 to 1, according to this piece right here. I also know negative 3 is equal to 2, and I also know f of 1 is equal the 2. I don't know what this curve likes, but I do know these 2 points exist. So this says there is at least one C where negative 3 less than C less than 1 such that f of C is equal to 0. So to get from point A to point B, do I have to hit 0? No, right? Usually that's the intermediate value theorem. In this case, I don't have to hit 0. I can go from here to here right away. So I know 1 is not true. It says there is at least one C where negative 3 less than C less than 1 such that f prime of C is equal to 0. What does that look like? Good, that looks like Rolle's theorem. We know that the f prime of C equals 0 belongs to Rolle's theorem, and we can use Rolle's theorem if the 2 points are equal. Well, according to this, isn't this to this equal? Oh, hold on. Isn't that an equal value, right? 2 to 2 is an equal value, so I know for sure 2 is true. Then it says there is at least one C where negative 3 less than C less than 1 such that f prime of C is equal to 4. So do I have to have a derivative that's equal to 4 here? I could have one, but it does not have to be true. So in this case, number 2 is our best answer. And once again, we know this because of Rolle's theorem. Let's take a look at the next one. It says the function f is continuous for negative 5 less than or equal to x less than or equal to 1, and f of negative 5 equals negative 2, and f of 1 is equal to 4. Which of these must be true? So once again, before I look at anything, I'm going to draw this graph out. This tells me I go from negative 5 to 1, and then negative 5, negative 2, and I also get 1 and 4. So let's look here. So if I read this, it says there is at least one C where negative 5 less than C less than 1 such that f of C is equal to 0. So what I notice is if I had to connect these dots, do you have, because remember it's continuous, so I know there's no holes, jumps, or gaps, do I have to hit 0? Well, yes, because one side's negative, one side's positive. So no matter how this graph looks, it's going to have to hit 0 at least once. So I know this one's true, and that's with the intermediate value theorem from last semester. Then it says that the f prime of C has to equal 0. Well, what theorem uses this? Rolle's uses this, and according to Rolle's, my two values have to be exactly the same. Well, is a value at negative 5 exactly the same as a value at 1? No, so I know this cannot be true. And finally, it says the function f has an absolute maximum value on negative 5 less than x less than or equal to 1. If I take a look, this is a closed interval, so remember, this is where I end and this is where I start. So is there a maximum in this graph? And that has to be an absolute maximum. Well, yes, because the absolute maximum value is the highest value possible, and we notice that that happens at 1. So in this case, we can say that 1 and 3 are both true. Alright, well that's it for today. We'll go over a lot of this in class on Monday. And good luck and have a good weekend. Thank you.